So the displacement time graph for two particles A and B are straight lines inclined at 30 degrees, sorry, 60 degrees and 30 degrees to the time axis as shown. So the diagram to that effect is so we have the first one is a displacement time graph. So this is A. A is inclined at an angle of 60 degrees to the time axis. Then B is also a displacement time graph. This is inclined at 30. The question is that find the ratio of their speeds or velocity. Find the ratio of their speeds. Okay, in linear motion, movement along one direction or in one dimensional, we use speed and velocity interchangeably when we are only considering the magnitude because the motion is in one direction. So speed and velocity are used interchangeably. Please, are we fine?
Yes, please.
So the problem, this is the problem on board. We have to find the ratio of their speeds. Let me, in about 5 minutes, pick the opinion of one or two of you. Yes, I want somebody who will just share with us how he or she thinks we should go about the problem. Anybody? Anybody? Apia Boatma, Xavier, any opinion? Can you share anything with us as to how we are to go about this problem? Okay, Kelly. I think Kelly is ready.
So please, I think you should use one of the trigonometric ratios to solve it.
Which one of them?
Tan.
So, okay, she thinks we are to use one of the trig ratios and tan. Okay, so Kelly, if we take tan, what else?
Tan of 60 degrees.
So if we take tan, the tangent of the angle 60 degrees, which is
1.732.
1.732. What again? Kelly, what else?
And then you round it to the nearest whole number.
And then that represents what?
The velocity or speed.
Of
that two of the A.
And then we take the tan of 30.
Yes.
Okay, you have good eyes. Nice one. Nice observation. Nice observation. Actually, that is the way out. But the finality is a problem. But that is it. You see, class, whenever we have a displacement time graph, the slope is equal to the slope of a displacement time graph is equal to the what?
Velocity.
The velocity. Good. So once look at something. This is this vertical component of the angle, and this side is change in displacement. The adjacent side is change in time. So when I find the slope of A, slope of A, which is equal to change in displacement over the change in time. Okay, there's it. Now, let's take the tangent of this angle. Tan 60 degrees will be equal to a hypotenuse, which is
√3/1.
hold on, I don't want the value, but from what we have, tan 60 would be equal to what side of the right angle triangle to what side?
Change in displacement.
So when we take the tangent of this angle 60, tan is opposite over adjacent. So this is also equal to change in the vertical, which is the displacement, over the change in the horizontal, which is time. Isn't it? Isn't it?
Yes, it is.
What it therefore means is that tan 60 is equal to the slope of A. Slope of A. And what does the slope of A represent? What does the slope of A represent?
The
velocity of A. Good. So tan 60 degrees would therefore be equal to the velocity of A or the speed of A. No, so that's the trick. When we take, let's also find the slope of B. Slope of B or the gradient of B will certainly be equal to the change in the offset. This is also delta S slash M delta T slash S. Change in the vertical over the change in the horizontal. So simply put, we also realize that this will also give us the velocity of B. Therefore, when we take tan of the angle of inclination 30 degrees, we have the velocity of B. Any question? Yes, Gideon is here. Gideon, I'm listening.
Sir, please, I can't see the board well.
Please, is it a general problem to all of us?
Yes, please. Oh, please.
Please, if you have that problem, Gideon, rejoin and then let's see, okay? I'm sure rejoining would fix the problem. Please, if you also have that challenge, rejoin. Florence, your hand is up.
Mr. Adrian, please, I don't get it.
You don't get what?
Please, can you go over it again?
Okay, so let's go over it. So let's assume nothing exists. We are to find the ratio of the speeds of this motion A and B. Now I have this. If I draw an equal vector, I have it. Now, the first thing you must understand is that the slope, or what we also call as a gradient of a displacement time graph. Time graph is equal to the speed. Is equal to the speed or velocity. I said in linear motion, speed and velocity are used interchangeably because we have one direction. So if the slope or gradient of the displacement time graph is equal to x velocity, then this is what I have. Florence, let's help me determine the slope of this line A. So slope of A, Florence will be equal to, yes, we want to determine the slope of A. That will be equal to okay, that will be equal to the change in the vertical, which is this. Delta change in the displacement over the change in the horizontal, which is time axis. Please, are we okay? So if, and this slope of A would have to give us the velocity of A or the speed of A. Florence, are you okay? So if the slope of A, if the slope of A is equal to this is the angle of inclination. When we use one of the trig ratios, and certainly it must be tangent because we don't have the hypotenuse. That we have here is the opposite and then the adjacent. We don't have the hypotenuse, and so we can't use a sine nor cos. So when we take the tangent of this angle, tan 60 degrees, and tangent is equal to opposite over adjacent, we have change in S over the change in T. So if tan 60 is equal to change in displacement over change in this, then we can say that this tan ratio must be equal to the velocity of A. Florence, are you okay? We must say that this trig ratio must be equal to the velocity of A because velocity of A is equal to h slope. Let's apply it to the second graph. If we are to find the slope of this, slope of B is also equal to the change in the vertical, which is delta SM over delta T. And so we also conclude that the slope of this would also give us the velocity of B. Please, class, are we fine? Let me adjust the screen. Good. This will also be equal to the velocity of B. Therefore, when we take tangent of the angle 60, 30, tan 60 will be opposite, which is delta S over the adjacent, which is delta T. Okay, and so we quickly conclude that this tangent of the angle would also be equal to the velocity of B. Now the next question is that find the ratio of their speeds. Maybe you want the ratio of the speed of A with respect to B. So speed of A with respect to or to the speed of B. Okay. Nana Akushia Jewa.
Sir, please, if they don't give you like speed of A is to speed of B, can you decide to do any of them like speed of B?
Exactly. This is an open situation, so you can decide to use B with respect to A or A with respect to B. Okay.
Okay, thank you.
So here I'm doing it according to the first diagram. So if the ratio is the speed of A is to the speed of B, then don't forget let me indicate this first. V of A is to the V of B is the same as V of A over V of B. Okay. Now what is the velocity of A? V of A on V of B is equal to VA. This is what we got. We got tan 60. Tan 60 degrees. VB we got tan 30 degrees. And what is tan 30? Tan 60. Tan 60 is root 3 on 1. It's simply root 3 over tan 30. Tan 30 is equal to 1 on root 3 or root 3 on 3. So this is root of 3 on 3. Therefore, root 3 on 1 times 3 on root 3. Please, are we okay with the mathematics here?
Yes,
No,
please.
please. Can you go back?
Tan 60 and tan 30 can be determined from your calculator. Okay. So if you press on tan of 60 is equal to root of 3. And tan of 30 would give you tan of 30 will give you 1 on root 3, which is the same as root 3 on 3. Okay. So you pick those details from your calculator. And when you divide it, this is it. And you use division of fractions. You have it this way. Therefore, the ratio of the velocity of A is to the velocity of B would be 3 is to 1. Would be equal to 3 is to 1. If the question is about velocity of B is to the velocity of A, then it will be equal to 1 is to 3. So that's the show. Kelly, Akosia.
Mr. Japi, she said we can only use tan.
Yes.
But you have the adjacent and you have the opposite too.
So yes, we have the adjacent here, we have the opposite. So
Oh, that's sorry.
better.
I've realized something.
Okay. So Kelly, are you okay?
Yes, please.
So this is how you have to approach it, rather. But interest, you have that good eyes to see tangent and 60 will be equal to speed of A and then blah 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 blah. But this is how you must go about it. Florence. Hello.
Please, you see the root 3 on 1 times 3 on root 3.
Come again.
The VA over VB. After you did the root 3 on the root 3 over 3. Please, why is the other equation? Why did you bring the root 3 at the down part?
Okay. Can I clean this side of the board? No.
Yes.
Maybe, I'm sure no. Okay, let me use this side of the board rather. Florence, this is velocity of A to the velocity of B. VA, we got root 3. So root 3 over VB, we got root 3 on 3. I want to change both the numerator, the denominator is a fraction. The numerator isn't a fraction. The numerator is just root 3. So if I want to change the numerator to fraction, what do I do? Here, views. I want to change the numerator, which is root 3 into fraction. What do I do?
Please, you get root 3 on 1 because any whole number is over 1.
Exactly. So this denominator becomes root 3 on 1, all divided by root 3 on 3. So this is the same as when you have a fraction A on B, all divided by the fraction C on D. Right, if you have such a fraction, how would you solve this? Or how would you go about this? Flores, I'm waiting. How would you go about this fraction? Okay, good about my help.
So that you maintain the first fraction
So
and
A on B,
you change the division bar into the symbol
times
and you reciprocate the
D on C. Good one.
yeah.
So that's what we have to do here. Okay. So this will be equal to root 3 on 1 times 3 on root 3. So that this and this will cancel. So you have 3:1. Florence, all is well.
Yes, please. Thank you.
Okay, I'm sending a question onto the platform for us to look at now. So give me a second. Juvia, are you there?
Yes, please.
Gideon, are you back? Oh, Gideon is still behind the door. Okay, so let me quickly send the question onto the platform so we look at. Okay, it's done. The question is sent.
What? Come come here video.
Do you have the question?
Yes.
please.
Okay, one of you to read the question for us.
A body starts from rest and accelerates to 2 meters per second square for 6 seconds. It maintains this velocity for 10 seconds and then decelerates to rest in 4 seconds. Sketch velocity time graph for the motion. Calculate the distance the body covers.
Okay, so 5 minutes to look at it and put your ideas on paper. Try solving it, then I come in, okay?
Yes.
All right.